Hello students, I hope you are able to hear me and see my slides also.
Yes, sir.
Right. Okay. So in the last class we have looked at the different instructions. Sorry, the if you we have looked at the different registers in 8086. So now we will from today's lecture we will be looking at the instruction set of 8086 and the other processors also. So let us begin with what is known as the addressing modes. So before that, we have to know what are the different kinds of instructions which are possible in 8086 and this family of processors. Okay. So the first set of instructions is the data transfer instruction. Now, what do you mean by data transfer instruction? Data transfer instruction, as the name suggests, it you will be able to transfer the data from memory to the registers or registers into the memory or from register to register between the registers. So it is basically to transfer some data among the operands. Okay, so this is called as a data transfer instruction. Now, arithmetic instructions. Arithmetic instructions are basically instructions like add, subtract, divide, multiply, like that. Okay, so these are called as arithmetic instructions. Now, logical instructions. Now, what do you mean by logical instructions? And, or, XOR, not, all these things are called as a logical instructions. Okay. Apart from that, you will be requiring to control the data branching. That means you want to change the control of the instructions from one location to other location. So that is called as a branch and program control instructions, jump instructions, call instructions, which you will be seeing. Okay, that is they are called as the branch and program control instructions, by which you can actually change the flow of execution of the instructions, right? So that is called as the branch and control instructions, right? So now in discussion, we will be using the move instruction, which is one of the simplest of the instructions. Okay, so this will be used, and using move instructions, we will be discussing the further topics that is called as the addressing modes. Okay, now move instruction, what does it do? In 8086, the syntax of move instruction will be move space destination comma source. Okay, so that means when you say move destination comma source, the data which is present at the source will now be moved into the destination. So that is what you will be doing using move destination comma source. So the data which is present at the source will be moved into the destination. The source value will remain the same. The data which is present at the source, it will remain the same, whereas the data which is present in the destination will be overwritten by the destination value. Okay, so we'll let us take some examples of the same thing. Okay, so like for example, just a second. Okay, so suppose you have this one second, let me take a pen. Okay, so let us say that I have that is it's not going into the pen mode. One second. Okay, so I have some destination. Let us say if I have destination like move, what is happening here? Okay, move. Let us say ax comma bx. Let us say that. Okay, So when I say move ax comma bx, okay, so it means that I will move the data which is present in the data which is present in bx will be moved into ax. Okay, so the data which is present in bx will move into ax. So thereby what will happen is the contents of ax will now change. Let us say that previously bx value was say 189ah. Okay, and let us say the previous value of ax will was say 035bh. Okay, now with the help of move, what will happen is now ax value will now become 189ah. Okay, so the contents of ax will now change to the contents of bx, whereas the bx contents will remain the same. Okay, so that will remain the same, whereas the contents of ax will now change. So that is how you the move will operate. Okay, of course there are different ways the destination can be. The destination can be a register or a memory location. Source can be a destination register or a memory location. Okay, so these are the possibilities. Of course, one thing which is not possible in move is you cannot move from a memory to memory in a single instruction. So that is not allowed. That's not possible. You can't move data from a memory into a memory directly. Okay, you can have a combination of the of a register and memory, but you cannot have a change from or a move from memory to memory. Okay, so we'll see a little more about this. Okay, now what do you, we have to understand this concept called as addressing modes. Now, what do you mean by addressing modes? Okay, so the processor basically will execute an instruction and it will perform some operation on the data. Okay, so the data that we have on which the instruction will operate is called as an operand. We have looked at this word before also. It is called as the operand. The data on which the instruction operates is called as an operand. Okay, so the operand basically is also refers to the destination or the source or the vice versa. So basically the destination and the source, they are called as the operands. Okay, so the instruction operates on the source and puts it in the destination. So both source and the destination will be called as an operand. Now, the data that is the operand may be part of the instruction. That means it is present inside the instruction only, or it may be a register of the microprocessor, or it may be stored at an address location in the memory. Okay, so the operand can be part of the instruction also sometimes, or it can be a register. In this case, for example, that we have seen here, this is a register. Okay, and this is also a register. Okay, I can instead have the source present inside the instruction only. We'll see some examples of those in a coming slides. Okay, the source can be an immediate data or some data which is present in which is part of the instruction itself. Okay, or the source can be a memory location also. Okay, both of the examples we will be seeing in the coming slides. So that is what we have to see. Now, addressing modes, basically we will tell, okay, which of the category these particular things are. Okay, whether the operands are registers, or whether it is a memory, or it is some part of the instruction, or whatever it is, that will be known, or that will be told by the type of addressing modes. Okay, so there's a query. What is the difference between a memory location and a register? Yeah, register is part of the instructions. It is a part of the your execution unit. Okay, which is present inside the microprocessor itself. Whereas the memory is it can be a ROM or RAM or any other memory device, or it can be a flash device or anything like that. Okay, so but register is part of the of the microprocessor only, specifically the execution unit of your processor. Okay, so it is present internally, and therefore when you access the register, the access will be very very fast, whereas when you access a memory location, it will take some time. Okay, so when you do a memory operation, whether reading from a memory or writing into a memory, it will take some time. My memory is not a part of a microprocessor, right? Okay, so depending on the type of the operands, or whether the operands are present inside the register or whether they are part of the memory or whatever it is, there are different kinds of addressing modes: register addressing mode, immediate addressing mode, direct addressing mode, register indirect, base plus index, register relative, and base relative plus index addressing mode. And there is a special addressing mode called as a scaled index addressing mode, which is part of your 80386 and 486 processors. Okay, let us look at each of these addressing modes one by one. Okay, for example, if I have the addressing mode or the instruction as move ax comma bx, which I have seen before. Okay, so this is called as a register addressing mode. Why it is called a register addressing mode? This is because both the source and the destination, okay, both of them are registers. Okay, as we have seen in the previous class, what are the different kinds of registers that you have? What are the registers that you have in 8086? Anybody on the chat, please? What are the different registers that you have on 8086? Anybody? Yes. What are segment registers? And AX, BX, CX, DX, these are called AX, BX, CX, DX. These are general purpose registers. SP, SPBP, SIDI, the AX, BX, CX, DX, they are multi-purpose registers. Okay, you have these special purpose registers also, and apart from that, you have their segment registers. Okay, so these registers that we are saying here, okay, this in the present in the register addressing mode, they can be either the special purpose, the general purpose, multi-purpose registers like AX, BX, CX, DX, or it can be also BP, SI, DI, and all those things also. Both of them are possible. Okay, so whenever you are operating on registers only, it is called as a register addressing mode. Okay, whenever you operate only on the registers, it will be called as a register addressing mode. Okay, some more examples of that is move DI comma SI. So this is also an example of your register addressing mode. Okay, and what else? So this is the most simplest of the addressing modes. Okay, so wherein you will have both the source and destination as registers. Now the second kind of addressing mode is the immediate addressing mode. For example, move AX 1420H. Okay, now what this will do? Basically, after this particular instruction is executed, this the contents of AX will become equal to 1420H. Okay, after the execution of this particular instruction, the register's content of AX will become 1420H. Okay, so this is called as an immediate addressing mode. Okay, so what is so special about immediate addressing mode? In the immediate addressing mode, okay, the source is actually some immediate number. It is not a register. It is not a memory location. 1420H is a some the is an exact value data which is present, which will be part of the instruction. Okay, 1420H in this case will be present in the as a part of the instruction itself. Okay, and the source is a register. Okay, So what will be the contents of the register after the execution of this instruction is present within the instruction only. So this is called as immediate addressing mode, because the data that you want to write into the register, that is your destination, will be present inside the instruction itself. Okay, so this is called as a immediate addressing mode. Okay, now the next addressing mode is the direct addressing mode. Okay, so for example, if I take the instruction as move ax comma 2340h within square brackets, 2340h square brackets. Now what will this instruction do? Okay, just a second. Now this particular instruction, let me take a whiteboard. Hmm, I think it's better to start with the Jamboard. Okay. Where do I? Yeah. Okay. So I'm the Jamboard is on my board also, so on my screen also. So you need not shift to this particular thing. Okay. Suppose I have an instruction move ax comma 2340h square brackets. Okay, now what will happen because of this is, now 2340h is actually a the offset of the memory location. So 2340h is actually pointing to a memory location. So as a after this particular instruction is executed, what will happen is ds colon 2340h. Okay, so this will give some address location. Okay, and this physical address will contain the source data. Okay, let us say that my ds value is, for example, 1000h. Okay, when I say ds colon 2340h, what will happen is I will calculate the physical address. How will you calculate the physical address for this ds colon 2340h? How do you calculate that? Anybody?
Converting into binary.
ds multiplied by 10 base h and then add 234.
Yes. ds multiplied by 10h plus 2340h. Okay. So in this case, it will become 10,000h, which will become 10,000h plus 2340h. So which will become 12340h. This will be the address. So it will go to the memory at 12340h. Okay, you will take the data from 12340h, uh, and also it will take 12341h. Okay, so it will take this both these values. Okay, okay, let us say that the values in this particular things are a, b, and 1 2. Okay, so these values will now be put into your ax. Okay, so ax will now become 1 2 ab h. Okay, now you may question, sir, why did you write 1 2 ab h? Why didn't you write ab 1 2 h? Okay, now here comes the concept called as little endian format. Okay, in the microprocessor in 8086 and the family of processor 8086 family of processors, the memory is stored in the little endian format. Okay, That means whichever is at the lower address will go to the lower end location. That is, AB will go to the lower address, lower register. Okay, lower 8 bits will be AB, lower byte will be AB, and higher byte will be 1 2. Okay, so it will be little endian format. Okay, this is called as little endian format. AB goes to the lower byte of AX, and 1 2 goes to the higher byte of AX. Okay, so this is called as little endian format. Little endian. Okay, I'm not sure about ENDIEN, I think. Okay, I'm not sure about the spelling. Okay, I think it is endian. Okay, so endian format. Okay, on the contrast, you have what is known as big endian format. Okay, in big endian format, if at all 8086 was, okay, it is not, but if it was big endian format, then in that case AX would have been AB 1 2 H. If 8086 was big endian format, it would, the result of this particular instruction would have been AB 1 2 H. Okay, but since 8086 is not a little big endian, it is little endian format, so it will happen this way. AX will become AB 1 2 H. Right, sorry, 1 2 AB H, it will become 1 2 AB H. Okay, so now what happens now? Let us now look at, this is called as the direct addressing mode. Why is it called the direct addressing mode? This is called direct addressing mode because the offset, okay, offset in the data segment is present in the part of the instruction itself. The offset of the data segment, this is called as an offset. 12340H is called as an offset. The offset is part of the instruction itself. Okay, now the difference between the move, please note the difference between the immediate addressing mode and direct addressing mode. In direct addressing mode, when I write the instruction, it will be say 1234H. I do not have the square brackets. However, in direct addressing mode, I have this particular square brackets, right, which because of which it will tell, okay, that this is a direct addressing mode, and the source is, in this case, source is a is a memory location. Okay, source is called is a memory location. So now you can say, now you, there is certain differences between the immediate addressing mode and the direct addressing mode, some more differences also. Okay, now in immediate addressing mode, if I specify an instruction this way, one move 1 2 or 1340H comma AX, if I say this, this will become a wrong instruction. This is invalid. This is invalid. Okay, why is that so? Anybody, why do you think is that this is an invalid instruction?
So the destination is of like physical data.
The destination is some data. Okay, source is a register, but destination is a data. It is like you are taking the data from the register, okay, and trying to put into an immediate value. Okay, you are trying to put it in the immediate value, which is not possible, which is not correct. Okay, and therefore this is an invalid address. This is not possible. This is an invalid instruction. Okay, you can't change, you can't write the contents of the AX into some immediate data. That is not possible. However, if I say move 2340H comma AX, this is a valid instruction. What will happen as part of this? is, again, let us say ds is equal to 1000h. Okay, so now what will happen, and ax, let us say, was ab 98h, let us say that, some example. Okay, now what will happen is, again, ds multiplied by 10h plus 2340h. Okay, so this will be, how much this will become? This will become 12340h. Okay, so this is the memory location. So this will be the memory location. So it will go to this particular memory location, 12340h and 12341h. Okay, it will go to this particular memory location and write AB98 into this. Again, 98 will come into the first address and AB will come into the second address. Okay, so 12340h will contain 98 and 12341h will contain AB. Okay, so this particular memory location will have the contents of AX after this particular instruction is executed. Okay, so this is also a example of a direct addressing mode, right? Okay, now then we have what is known as the one second, yeah, the next instruction is the register indirect addressing mode. This is an example. This is next address is register indirect addressing mode. Move ax comma bx in brackets. Now what will happen after this? Okay, so ax will become the contents of ds colon bx. Okay, so let us go to the Jamboard again. Okay, I have move ax colon bx. Okay, now again, let us take some values. Okay, let us say ax previous value is 1234h. Okay, let us say the values of ds is 1000h and value of bx is say 4000h. Let us say that. Okay, so now what will happen is, this particular thing will will take the data contents of a memory location which is pointed by bx and put it into ax. That is what it will do. Okay, it will take the contents of a memory location which are pointed by bx and put it into ax. Okay, that means ds colon bx, which will be equal to 1000h multiplied by 10h plus 4000h. So this will become 14,000h. Okay, so it will go to a memory location, okay, whose address is 14,000h. It will take the values from there. Okay, let us say that I have AB and 1 2. Okay, so now AX will now be 1 2 ABH after the execution of this particular instruction. Okay, or let us take some other value. Where is this? Yeah. Let me take some value here. So say let me take 98. Okay, so the contents of AX after this execution will be 98ABH. Okay, so the source is a memory location whose destiny or which is pointed by bx. Okay, and the contents of that memory location. Okay, now bx will be used to calculate the address location. So bx will provide us the offset to data segment register. Okay, this is the offset now. Okay, and that will be combined with DS to form a physical address. It will go to that particular memory location, and that data will now go into AX. Okay, so this is called as the this is called a register indirect addressing mode. Okay, why is this called so? Because the register is indirectly pointing to the memory location. Okay, the register is indirectly pointing to the memory location. Okay, again I can have this way also, move bx comma ax. So this is also a valid instruction. Okay, this is also called as is also a valid instruction. Okay, so in this case the inverse will happen. The contents of ax will go into the memory location which is pointed by bx. Okay, fine. However, there is some caution which we have to exercise in this particular addressing mode. Okay, it is not that any register can be used to point to the memory location. It is not that any location, any register can be used to point to the memory location. Why is that so? The reason being that in the last class that we have seen, okay, let me see if I have the slide. Yes, in the last class we have seen that there is a special combination that we have. Okay, this is a special combination that we have. The dx, okay, for example, CS value will combine with, if CS is the segment, if you are wanting to point to a memory location in code segment, it will combine only with the IP. Okay, similarly stack segment will combine only with BP or SP. DS data segment will either combine with BX, DI or SI. Okay, and ES will combine with DI only. Okay, so therefore what will happen is I cannot use any register I like for pointing to or providing me the offset. In this case I have used BX. Okay, BX can be used. When BX is used, it will combine the data segment. Okay, if I use SI, that will also combine with data segment. When I use DI, it generally points to the ES extra segment, but it can also point to the data segment with certain conditions. Okay, so if I specify an instruction like this, okay, move AX colon C or comma CX. Okay, here what I'm trying to do is I'm trying to use AX as an offset address. But from this slide, I see that AX cannot combine with any of the segment registers. AX cannot combine with any of the segment registers, and therefore this is not a valid instruction. It is invalid instruction. Okay, so this cannot work. Why? Because you are trying to use AX as a offset register, or you are using AX to provide the offset address, which is not possible because AX does not combine with any of the segment registers. You cannot combine DS with AX. Not possible. Right? So therefore, this particular, if you want to combine with DS, it has to be either BX or SI or DI. Okay, so move, if I say SI comma AX, this is valid. Okay, if I say move, okay, BP comma AX. Okay, now what will this do? Please look at this particular table. BP generally combines with the SS, stack segment register. Okay, and therefore what will happen as a result of this instruction is SS colon BP Okay, will give the memory location. Okay, the contents of this will be changed to AX. Let us say that SS is 1000 H, BP is 2000 H, okay, and AX value is, let us say, 189 AH. Okay, 1 second, please hold on. So I will combine SS colon BP, which will become SS colon BP will be how much? 12,000 H. Again, 1000 multiplied by 10 will become 10,000 H, plus 2000 will become 12,000 H. Okay, so now 12,000 H will be the memory location. Into this particular memory location, I will write 189 AH. Okay, so it will go into the stack segment. It will go into the stack segment. Okay, so that is what will happen in this particular thing. Okay, so AX will go into this particular memory location. Okay, why? Because you are using BP. BP generally combines with SS, or generally what? It always combines with stack segment address, and therefore now when you when you say move BP brackets comma AX, it will actually go into the stack segment, not the data segment. Okay. Okay. Now what about DI? Generally DI will actually combine with the extra segment. Okay, when I say move DI brackets AX, okay, generally it will combine with extra segment. Okay, so the contents of, or the memory location which is pointed by ES colon DI, it will be written the values of AX. Okay, however, I can actually tell this way: DS colon DI comma AX. Okay, I'm telling here explicitly that DI should combine with DS, and that should provide the memory location. Okay, when I specify this way, this is called as a segment override. Okay, generally DI combines with extra segment ES. However, here I am trying to change it, and I'm saying I want to make DI combine with data segment register, and therefore I'm providing a segment override. I'm saying move DS colon DI brackets comma AX. Okay, now in this case DS colon DI. Okay, so that will be used to provide the memory location, and into this particular memory location I will write AX. Right? Fine. Are you getting it? Right? If SP is used, will SI be automatically selected? SI nahi, SS. Stack segment will be automatically used. No, there is SS, SP, there is an issue. Okay. SP is there is an issue. You cannot directly do that. There are certain things which we will see in the later classes. Okay. When we say BX, we are referring to the data that is content BX brackets. When we say BX, we are referring to the data that BX contains. When we say BX brackets, we are referring to the data pointed by the memory location pointed by BX. Yes. Okay. Right. Can segment override be used with, can be used only with DI? No, it's not with only with DI. It can be used in other locations, other places also. There are certain other places. We'll see that. Okay. Okay. Let's come back. Okay. The next addressing mode that we are looking is base plus index addressing mode. Now, what do you mean by base plus index addressing mode? For example, you have move AX comma bx plus si within brackets. Move ax comma bx plus si within brackets. Now what this will do? Okay, so let's go back to the Jamboard again. Move ax comma bx plus si within brackets. Okay, so now what this will do is, let us again take some values. Ds, let us say as 1000 h. Bx, let us say is some 1200 h, and Si, let us say is 0010 h. Okay, now Bx and Si, both of them combined will form the address location, will combinedly form the offset for an address location, and that will be used, that offset will combine with ds to form the physical address, and that will give the memory location from which the source data will be present. Okay, now what does it mean in this case? Okay, so this will become ds colon bx plus si. Okay, so that will be the source memory location, source address location. So this will be a source address location. Okay, so in this case the source address location will be 1000 multiplied by 10 plus 1200 plus 0010 h. Okay, so that will become 10,000 h plus 1210 h. So that will become 1121 I'm sorry, 1121 h. Now this will be the memory location. So I'll go to a memory location. One two one one 210 h and 11211 h. Okay, so it will have some data. Let us say it will have 2010 h. So after the execution of the instruction, the AX value will be 1020h. Okay, so basically this will give the memory location, and I will take the memory location, that the contents at this particular memory location, and that will be transferred into AX. Okay, that will be transferred into AX. Okay, so this is called as a base plus index addressing mode. Base plus index addressing mode. Okay, why is this called so? Okay, because bx will provide the base, okay, and index will be provided by si, okay, and that will tell which is the addressing mode. Okay, base plus index addressing mode. Okay, now apart from this, okay, bx plus si, there are certain other combinations also which are possible. There are certain other combinations which are possible. For example, you have bp plus si. Okay, let us take this example. Now let us say that I have an example. Move ax comma bp plus si. Okay, when I have bp plus si, okay, because bp will now provide as the base, si will provide as the index. Okay, now since bp is the base, okay, this bp will always combine with the stack segment, not the data segment, and therefore as after the execution of this instruction, ss colon bp plus si, this will provide the memory location, and that this data will now be moved into AX. Okay, let us say SS was 2000 H, BP is say 0300H, and SI, let us say, is 0100H. Okay, so the address location that it will form together will be SS into 10H plus BP plus SI, so which will become 20,000 H plus 400H, 0400H, so that will become 20400H. Okay, so this will be the memory location. Okay, so it will go to a memory location. Okay, whose, let us say, it will go to a memory location. Okay, whose memory location, let us say this is 20400H, 20401H. Okay, so let us say it is 1 2, this is 3 4. Okay, now AX value will now become 3412H. Okay, this is in stack segment. Okay, so basically BP is telling me what is the segment that I will be using. It is not about SI. BP will actually tell me which segment I will use, right? Okay, so then we have last is the, or one of the things. Okay, let us continue in the next class. So we have two more addressing modes to cover, that is the base relative plus index and the scaled index addressing mode. Okay, shortly I will tell base relative plus, I'll take an example in the next class. However, I'll just tell you move AX comma BX plus SI plus 10. This will actually tell that BX plus SI plus 10, this together they will form the offset. Okay, together they will form the offset. Okay, I'll just end with this. Scaled index we will see next time. Okay, BX plus SI plus 10, so that will form the offset. Okay, let us say again here BX will determine which segment I will use. Okay, let us say the DS value is 1000H. Okay, BX is, let us say, 2000H. SI value is, say, 3000H. Okay, so now what will happen? DS multiplied by 10H plus BX plus SI plus 10H. Okay, so that will become 10,000H plus 2000 plus 3000 plus 10. 2000 plus 3000H plus 10H. So this will become, this is also H. So this will become 15,110H. Okay, so it will go to this particular location, 15,001H and 15,011H. Okay, and AX value will now become 12ABH. Okay, base relative plus index. Okay, relative to the base I am adding 10, to that I am adding index, so this will become base relative plus index addressing mode. Okay, again in base relative plus index mode, relative addressing, base relative plus index addressing mode, or base plus index mode. So both the destination or the source, either of them, now it can be the either way around also, you can interchange this thing also, that will also be a valid. That is, this will be your destination, this will be the source, that also is possible if I interchange them, that is also possible, right? Okay, so fine, let us end here. If you have any queries we can look at it. Yeah,
Sir, if
Addressing.
sir, if BX plus SI is used, how is the priority given, sir? For BX or SI, how will we decide? if any two registers are there.
So I'm sorry, can you repeat?
Sir, if two registers are there in that BX plus SI, suppose. So how is the importance given to BX instead of SI? How will we decide that?
That is given, that is set. That is already, no, there are only one or two combinations like this. Here, BX will provide the base. Importance is given to BX. Okay, there are only very few combinations you have. It's not that many combinations you will have. We will see in the next class what are the only possible combinations that you have. Okay, there are only few or very few combinations, and they are determined, predetermined combinations. You can't have a like different combinations, permutations and combinations of registers to form the this base and index. Okay,
Okay.
right. Okay, in one example earlier, sir used base as of SS as 1000 Hz, and how can it be same for both DS and SS? Yes, they can combine. They can be. See, I'm not saying these are all not immediate. Sorry, you can say dependent examples that I have taken. They are just some random examples that I have taken. However, it is quite possible that DS and SS values can be the same also. The contents of DS and SS, they can be same also. In that case, the segments, they will overlap with each other. Right? I think Aman, you have understood this. The segments can overlap with each other also. Move AX comma BH. No, it is not. It's not actually valid, but the processor will do some kind of a. Strictly speaking, it is not valid. Vignesh. Strictly feeling, it's not valid. But the process sometimes will do it. Will make it valid. That is what it will do is the 8-bit value, it will zero pad. That means it will have the most significant byte as 000 and 00H, and it will move into a 16-bit register sometimes. Okay, but strictly speaking, it's not valid. Move bx comma ax was invalid, but move di. No, moves bx brackets ax is valid. That is not invalid. That is valid. That is valid. Move bx in brackets comma ax. That is valid. What happens if the addition of BP and SI has an overflow? That overflow will be neglected. Will be neglected. That overflow, that will be a special case. We have to look at a special case in that case. Move AX brackets comma ABC, where we have ABC to where what can we have instead of ABC to make it valid? It can be register. No. AX can never be used for register indirect. This is any whatever you have ABC. It will be invalid only because AX cannot be used for pointing to. It cannot be used to specify an address. It cannot be used in register indirect addressing mode. AX can never be used in register indirect mode. So your instruction move AX brackets comma ABC. ABC, no matter whatever it is, it will be invalid. Sir, why couldn't we pad 8-bit 0 in case of register indirect indexing, and why couldn't we? Why did we store data of two why did we store data of two memory locations in destination there?
So may I speak out my question?
Yeah, sure.
Yeah.
I'm not able to understand.
Yeah, that's right. So my question is that you just said that if like in Vignesh's question that we can't add 8-bit to 16-bit, we can't
You
move
can't.
from 8-bit, so we add a padding there. So in register indirect indexing, why was it the case that let's say the final destination takes me to 14,000 H? So in the destination, why do I store data of 14,000 H and 14,001 H in the destination?
Right. The reason being that See, now your source will tell whether you are moving an 8-bit data or a 16-bit data. AX. Okay, if I say move, say BX brackets and AXH. Let us take that example on my Jamboard itself. Okay, let us take. I have the same example that I have. Okay,
Okay.
move BX brackets comma AX. Now this is a 16-bit register. Okay, this tells me whether you're transferring a or moving a 16-bit data or 8-bit data into this memory location. If I had this, I'm moving an a 16-bit data, and therefore let us say 14,000 H is the memory location that will come out. So 14,000 H and 14,001 H will have that particular data. However, if I say move BX brackets comma AL, okay, so because this is an 8-bit data, so it will just go to 14,000 H only. I'm sorry, it will go to 14,000 H only. 14,001 H will not be affected. Why? Because you're just transferring AL, one byte of data or 8-bit data, right?
So in that case, if my register is 8-bit, then only I will be padding the output.
Here, there's no padding. There's no padding that you will do. This is a valid. The example which Vignesh has given is move say bx comma al or something like that. Okay, so this is an 8-bit register and this is a 16-bit register. Okay, you are trying to move 8-bit data into a 16-bit data. Okay, strictly speaking, this is not valid. Strictly speaking, this is invalid. However, some compilers, what they will do is they will take AL value, they will zero pad it with 00 and zero pad it and then move into BX. Okay, so AL, let us say, was before, sorry, AL for example was say 89H. Okay, so then BX will now become 0089H. The compilers will do it. However, this is not a strictly, it is not a valid instruction, right?
Okay.
However, there are certain other instructions which can make it valid, something like move ZX. Move ZX BX comma AL, this is a valid instruction. However, move ZX is not available in all the processors. It is available, I think, in 80286 and above. Okay, it is not available in 8086 as such. So that is why we will avoid this situation.
And so just one final question that if we finally move to 14,000 H, then why not only store 14,000 H?
Here inside this?
Yeah.
Now the reason being this, now I need 14,000 H. Okay, at a given another point of time, I want some other memory location to be specified. Okay, so what I can do is, now let us say that I'm storing 10 different values, okay, in consecutive memory locations. Now what I will do is, instead of writing the instruction 10 times, I will have a loop where I will keep on incrementing BX 10 times. Okay, BX, and then I will add one to it and do the move instruction again. Then add one more and do the move instruction again. Like that, I will do 10 times. Okay, by this, what I will be able to do is, by using a loop, I will be able to write the thing in 3 instructions rather than 10 instructions. Okay, so like I will say this way, say move BX comma AL and then add, let us say, BX comma 2. Okay, and then I will say loop. Okay, you will not understand many of these things. What I am doing here, you will not understand. So basically, I will do looping 10 times. By this, I can transfer 10 bytes, or in 10 locations, I can transfer AL or AX, whatever it is. Okay, this I can do 10 times. So by which now what will happen? This will give me a privilege of doing 10 times without writing this instruction 10 times. Otherwise, if I would have told move 14,000 H AL, then I have to write, 10 times. Now I have to write 14,000 2AH, 2H, then 14,000 4H, like that. I have to write 10 instructions. Length of the program will increase. Further thing is, suppose I want to relocate. Okay, if I want to, you can't actually say 14,000 H, you have to say some 4,000 H or whatever it is. Okay, if I want to change the location, segmentation, okay, relocation, if I want to do, I will not be able to do it so easily if I specify the direct data always. Right? So here I have the privilege of changing the value of bx according to the program's output. Right? Right. Right.
Thank you, sir.
Okay. Any other queries? Right. If that is so, we can end the class. Okay. Thank you. Thanks a lot.